Now recall what we said. Eventually, the learning curve will reach something called a steady state. Basically, beyond this state, we will stop learning, meaning the average time or cost per unit will stop falling. And thereafter, it'll take the same amount of time for any subsequent units or batches. So how do we incorporate this into our calculation? So for example, if we say that the steady state is reached after we produce 60 units, right? And we need to find how much time it took to produce 80 units in total. What would we do, right? So for this purpose, let's assume that A, the time for the first unit is 100 hours, and R is 80%, okay? The way it works is, the steady state is calculated based on the fact that up till 60 units we continue learning. So the last unit for which we learned something would have been the 60th unit. And we can find the time for the 60th unit by taking the total time for 60 units minus the total time for 59 units. The time for the 60th unit will then be projected forward for all subsequent units to do the calculation. Okay? So let's start by first finding the total time taken for the first 60 units, which would have been under the normal learning curve. For that, we'll need to use our calculator. So based on the learning curve formula, the total time for 60 units would be A 100 into 60 raised to power of B, which is log of 0.8 in this case, over log of 2. And then we'll need to multiply this by the number of units, which is 60. So the total time for the first 60 units would be 60 raised to power log of 0.8 divided by log of 2 into 100 to get the average time for the first 6 units into 60 to get the total time. So 1605 hours. Okay, 1605 hours. Let's note it down to the decimal places, 0.88, right, to be more accurate. Okay, now after that we need to find the time for the 61st to the 80th unit to find the total time for the first 8 units. For that we need the steady state time, for which we'll need to find the time for the 60th unit. The 60th unit's time would be found with taking the total time of 59 units and subtracting that from this value. So log of 0.8 over log 2, and this time we'll multiply it by the number of units, 59. Okay, so this is what will always be the case for a steady state calculation. So if the steady state was at 117 units, you'd find the total time for 117 units minus the total time for 116 units, and that'll be the steady state time for any subsequent units. Okay, so only 1 unit less basically, just like we do for incremental time. 59 raised to power log of 0.8 divided by log of 2 gives us 0.269 times 100 times 59. We get a total time of 1587.69, right? 1587.69. So the difference between these two is, we can take this as is, it's going to be negative, plus 1605.88. we get 18.19. So the 60th unit took 18.19 hours to make, and any subsequent units will take this much time. Now, how many subsequent units do we have? 61st to 80 units means 20 subsequent units. So we multiply this by 20 and we end up with 363.85, right? So the first 60 units took 1605, the next 20 took 363.85 for a total of 1605.88 plus this amount, 1969.73. So that's how much the first 80 units took to produce when the steady state came in between. So remember, steady state calculation, find the time for the last unit produced before the steady state and then multiply it by any subsequent number of units that you need in order to perform your calculation.